Welcome to Convent House. This talk is an extension of the introductory lectures to pathology, which included some material on evolution for undergraduates. The reason it was there is because it's an interesting topic, and I think it's something that everyone in the biological sciences should be aware of, even if evolution isn't their primary field. And it generated some feedback year on year. A few years ago, I had some feedback from one of the students saying that he'd enjoyed my lectures, but he wished I didn't teach evolution because it wasn't true. And I replied that I taught the theory of evolution and that it was up to the students to decide what was or was not true. This student's objection was a result of him being what I call a hard creationist, which is someone who believes that the Lord God made absolutely everything as it is, every beetle, every wasp, every single individual species, this is known as essentialism, in its final form. This is from a splendid hymn which was written for little children, and I used to sing it when I was a little child, although by that time someone had expunged the key verse, "The rich man in his castle, the poor man at his gate, God made them high and lowly and ordered their estate." This is actually one of the more sensible verses in that lovely old hymn, "All Things Bright and Beautiful," which is very nice for little toddlers, but is theological nonsense. As Monty Python puts it, all things dull and ugly, all creatures short and squat, all things rude and nasty, the Lord God made the lot. I'm not going to discuss hard creationism because I think that's a theological topic, and there are other ways of believing that the creatures on earth are God's divine handiwork without thinking that they were all created individually. So in this talk I will be considering various theories of evolution and how they were influenced by Christianity, by transcendentalism, and by other factors, political and social, of the time. One of the difficulties in teaching evolution is that nobody really understands it. Even the people who thought up the theories apparently didn't really understand them, and there's a whole light industry of scholars critiquing Darwin and saying what Darwin actually meant and what he actually thought rather than what he apparently said. And if even biologists and historians can't agree on what Darwin actually said, how can we be expected to agree? So everything in the talk is, I'm afraid, oversimplified. The commonest error I find in people who are not working in the biological sciences, and sometimes in some people who are, particularly in the medical field, is that they think that Darwin discovered evolution, or if they're a bit more sophisticated, proposed the theory of evolution or proposed a theory of evolution, and that having done so in 1859, everyone else had this kind of facepalm moment. So that's why all these animals look so similar. We were wondering about that. Isn't it brilliant? Well, of course, it didn't happen like that. There had been endless speculation on why different creatures appear to show very strong homologies and why there seems to be a series, and we will be looking at some of the explanations that were put forward to that, because I think that by understanding the different possibilities, it broadens the perspective on evolution. It's a subject that cannot be understood apart from its social and historical context, and while I have a great deal of sympathy with people who don't want every topic turned into something political, the development of theories of evolution undeniably was and remains political, which is one reason why it generates such a heated response. It had long been accepted that there were physical similarities, homologies, between different kinds of animals, and that they can be arranged to make a kind of series or graded sequence, the so-called Great Chain of Being. The chain of being itself does not imply evolution, which is change, species change. It simply implies that there's a series. You can arrange a series of jugs on the shelf going from small to large in a graded series, but that does not mean that the jugs themselves evolve in size as time passes. So the development of evolutionary theory is suggesting that life on Earth has not always been the same. It's changed over epochs, over long geological periods of time, and the business of evolutionary theory is to propose mechanisms for this. So we begin with Jean-Baptiste Pierre-Antoine du Monet Chevalier de Lamarck. They have great names in this business, who proposed what I think is the first coherent theory of evolution, Lamarckism. Probably no genius in the field of biology has ever been so reviled, because all anybody knows about Lamarckism is that it posits the inheritance of acquired characteristics, and the example that's always given is that giraffes are stretching up to reach the leaves on the tops of trees so their necks get longer, and then this characteristic is passed on to their offspring through the inheritance of acquired characteristics, Lamarckism. Now, in fact, that's obviously not an example from Lamarck, and it's even a misrepresentation of what he wrote. His theory does rely on use and disuse. Features of the body that are used will develop, and these developments will be passed on. Those that are not used will fall into desuetude, they will atrophy, those will not be passed on. So yes, he does posit inheritance of acquired characteristics, and there's no quicker way to end any discussion about evolutionary theories than by telling someone that their ideas amount to Lamarckism. Lamarck presented evolution in terms of two opposing forces. The driving force is la force qui tend sans cesse à composer l'organisation, the force that perpetually tends to make order. By conceptualizing it in this way, it avoids the involvement of God, although there perhaps isn't a great deal of difference between the classical God of theism and the force that tends to produce order, except that some people will find the impersonal force rather more acceptable. It has overtones of Taoism, which of course Lamarck was not aware of, and I think for modern readers it probably evokes the force in Star Wars, which is kind of nice and mysterious and mystic without actually committing anyone to really believe in anything very much. So the driving force behind Lamarck's evolution is a kind of halfway house between having a deity involved and having a process that drives itself. The opposing force is the adaptive force, l'influence de circonstance, and this is very much of its time. Lamarck is living in France that's approaching a revolution, then having a revolution, and then having had a revolution, and he is himself prepared to adapt to circumstances. He is in charge of the Jardin du Roi, which he renames the Jardin des Plantes after the revolution as being slightly more in keeping, and rather like the Vicar of Bray, he manages to hang on to his position, whoever is actually in charge. Lamarckian evolution is progressive. There is a march of nature, and that again fits in very much with the times, because revolution can only ever be acceptable if there's a concept of progress, if the revolution is a way of making things better, and if there is a general tendency for things to become better. Revolutionaries will never accept the possibility that a revolution may simply make things worse. Change is always good, basically. And Lamarckism is also gradualist. There are no catastrophes in the history of the world. There is a slow, inexorable progress. And in this he contrasts with Baron Cuvier, who was a proponent of there being mass extinctions, which he, Cuvier, called the Earth's revolutions. Most of the history that most people who aren't professional historians are exposed to is so-called Whig history. The Whig Party was a British political party, somewhat analogous to the Liberals, and their philosophy and the philosophy of Whig historians, that doesn't mean the historians actually are liberals, although they might well be, but just that they have the same philosophical approach, was that everything is always getting better. There is this march of progress, and we tend to see that in history, and therefore we tend to read evolution as a march of progress, even if it isn't inherent in the theory. So we must be aware of this when we consider some of the later theories, which we will do now. France at the time of the Revolution was the centre of biology and anatomy research and teaching through the triumvirate of Cuvier, Lamarck, and the proponent of the next theory that we're going to look at, Geoffroy Saint Hilaire. He was heavily influenced by transcendentalism. The problem with transcendentalism, like evolution, is that it's quite difficult to explain it, and even the people that write about it often don't really understand what it is. Transcendentalism is a philosophy which emphasizes homologies between different things. So, for example, in biology, the base of the skull is often said to be a modified vertebra. The limbs can be said to be modified fins from fish. Transcendentalism is prepared to go much further than that, and, for example, Robert Knox sees the sphere as the form of the cell, as well as being the form of the world and the form of the universe. So it becomes, in the higher levels of transcendentalism, a very speculative and intuitive science. Transcendentalism always requires a certain amount of intuition because it depends on recognizing similarities between different things, and the relationship between them is known as formalism. Different animals are related because they share a common form, and they share a common form because they share a common development. Geoffroy studied monsters, which we would now call birth defects, but that very terminology, by calling them birth defects, we are implying that there's something wrong with them, that there's a form that was the target and the target hasn't been hit, so we're looking at a defect. Whereas Geoffroy would have called them monsters, a monster being a showing forth. Monsters, large variations, large genetic differences between parents and offspring are central to Geoffroy's theory of evolution, because these monsters, which are later going to be called hopeful monsters, which is a phrase a lot of people will be familiar with, are ready to occupy new environments when they arise. This evolutionary theory is a variety of saltationism or saltatory evolution, because evolution proceeds by jumps rather than gradually, so the opposite of saltationism is gradualism. Geoffroy writes, monstrosities could become the founding fathers or mothers of new species by instantaneous transition from one form to the next. What drives evolution, changes in the environment. This is a step from Lamarck, who requires some mysterious intrinsic force to drive evolution. For Geoffroy, the environment itself drives organic change, because when a new environment arises on Earth, mutations will fill it. It's rather like when trams were introduced into London. They had to stop somewhere, so people converted the fronts of their houses into little shops to sell things to the people waiting for trams. And this was the origin of the small London shops that are stuck on the fronts of people's houses. So the opportunity arises and something will mutate in order to fill it. The transcendental component states that all animals are variants of a single common form. Everything is made from basically the same materials through embryonic development. Embryonic development can be divergent, but the same basic principles, the same basic architectural principles form every creature. Another way of looking at this is that it's a kind of developmental constraint. The embryo can only make certain forms. It's rather like buying a Lego set. Lego is wonderful stuff, and you can make all kinds of things out of it, but you can't make everything out of Lego. You can't build a nuclear reactor. And in the same way, an embryo can't make absolutely any form. As far as I know, there are no land animals that have a tripod leg structure. It might work very well, but embryos just don't seem to be able to make three-legged critters. Geoffroy suffered a bit from being in the shadow of the more powerful Cuvier, who flourished and became very fat after the revolution. The two men engaged in a famous debate, and there's still some dispute over who won, but in practical terms, at least at the time, it was Cuvier, because Cuvier was a teleologist. He believed in purposeful development. Cuvier had looked at the fossil record. He knew that there were discontinuities. He proposed that there were mass extinctions, the Earth's revolutions, but he did not have a natural mechanism for driving evolution. There was a purpose to the whole thing. Cuvier was a Christian. The purpose of evolution was to make the animals that it did, whereas Geoffroy was a formalist. There were patterns in nature that the transcendentalist could recognize. This was because all animals derived through the same embryological processes, and changes in environment led new forms to flourish. A fourth, somewhat lesser known Frenchman was Henri-Marie Ducrotay de Blainville, who wrote of the biological series, or great chain of being, that extinct forms fill up the gaps in the scale, so that out of the living and the extinct, the present and the past, is formed one great chain of beings. In other words, there were gaps either because those forms had died out, or, as would be proposed by his pupil Robert Knox, that those forms hadn't developed yet. De Blainville and Knox are transcendentalists. They propose a natural order in which all possible creatures are represented and can be arranged as a chain of being. The chain is a series, but it's not a progressive series because there's no filial relationship and there are no lower or higher forms. It's rather like a spectrum of development. So from monad, the simplest unicellular creature, to man, is a whole spectrum going through fishes and amphibians and reptiles and mammals, and this will be worked out in the fullness of time. Knox went to France and studied under all of the French biologists we've mentioned, except Lamarck, whose work he shunned. Then he returned to Scotland and London and produced his own theory of evolution, which is somewhat diffuse, as unlike his French colleagues, he did not have a permanent academic post, but made a living teaching anatomy. As in Geoffroy's theory, new species were formed by mutations in embryonic development, so they were hopeful monsters. Knoxian evolution was not teleological. There was no intended outcome, there was no purpose, no progress, but there was change when potential forms existed in actuality because they occupied a new environmental niche. Knox knew that there are minor variations within a brood between the offspring. These minor variations, of course, are central to Darwinian evolution, but Knox had little regard for them. He thought that because an animal was suited to its environment, any minor differences from the ideal type would be removed by selection. So while he's perhaps considering a kind of Darwinian natural selection, in Knox's case it's operating to keep a species close to its archetype or ideal form. In order to occupy a new environmental niche, it needs to undergo a macro mutation. This is not so strange as it sounds, because one of the big problems with Darwinism for many years would be how new species form, the process of speciation, through gradual change. While Knox was not an embryologist, the embryo itself is crucial to his theory. Biological variation arises because of variations in embryological development, and these can be great or small. It's well known that the embryo apparently passes through a chain of creatures that can be arranged along a scale, and this is known as the Meckel-Serres law. Ontology recapitulates phylogeny. The development of the individual reproduces the evolution of the species. So the human embryo can be seen as passing through a fish form, an amphibian form, a reptilian form, and so on. I emphasize that it can be seen as that because what is actually happening is that the earlier the embryo, the more homologies there are between different species. So an early human embryo looks a lot like an early frog embryo, but it does not look like an adult frog. The Meckel-Serres law is one of the many aspects of evolutionary biology which, while it's proven wrong by observation, is nevertheless the sort of idea that, as Stephen Jay Gould put it, seems to have something in it. With our modern knowledge of genetics, we can say that a relatively small genetic change could have very large effects upon the embryo. We can also say with our knowledge of embryology that an embryo cannot simply make any form. It has to be a going concern throughout its development, so some mutations will be fatal in utero if you're viviparous, and so that is why at least a third of all human embryos will abort spontaneously, many of those will have genetic anomalies that are not compatible with development. As I've summarized it here, Knox envisaged a Cuvierian cycle of terrestrial revolutions, sudden environmental upheavals that created suitable milieu for some of the countless new varieties churned out by the relentless operation of transcendental laws. In modern parlance, he proposed a theory of saltatory evolution, in which deformations in embryonic development produced hopeful monsters that, if fortuitously suited to the prevailing environmental conditions, could give rise to new species in a single macroevolutionary leap. The reason I'm labouring Knox's contribution is that he alone of the theorists I discuss has been largely forgotten, and this is mostly due to his anomalous position within the academic community rather than to any paucity of thought, and as his biographer I clearly have a vested interest in restoring his contribution to evolutionary science. The terrestrial environment is constantly changing, and as it changes, eventually every possible form will have its chance. Every dog will have its day. It's interesting to speculate from a philosophical point of view, are there any potential forms in Knoxian evolution that will never actually get to exist? But it's a sort of non-question, because in any evolutionary system, the only creatures that can evolve are the ones that are suited to their environment, and if the right environment is not there for a particular creature, then the creature is not going to happen. So from Knox's point of view, the series works itself out in completeness. There's no hierarchy in Knoxian evolution. Every form that we see is a terminal development. Extinctions occur in response to changes in the environment, and eventually, just as all possible forms will have their opportunity to exist, all will become extinct. In his work on race, he applied this to the races of men. Extinction would be the eventual fate of all races, since each was destined to run like all other animals a certain limited course of existence. It matters little how their extinction is brought about. Men might claim their own race as the highest development, but so would have reasoned the Saurians. Knox's work is characterized by a bleak pessimism, which I think derives from the Calvinism of his native land. I clearly don't have time to explain the theological tenets of Calvinism, but it is deterministic in that while for most Christians life from creation of the soul to death and to eternity is a challenge, a veil of tears, is God's way of forming the human soul and developing it. In Calvinism, all are predestined to their fate. So-called double predestination is the theory that from the beginning of time, God has ordained who will go to heaven and who will go to hell, and there is absolutely nothing that one can do about it. If God chooses to save you, then you are saved from the beginning of time, immutably. Knox's evolutionary theory has been described as a kind of deconsecrated Calvinism. Every animal has its predetermined fate. It will come into existence, it will pass out of existence. There is no struggle for life, as Darwin will put it. There is merely the working out of an overarching purpose which, in a transcendentalist viewpoint, does not require an active deity. Interestingly, when Knox read On the Origin of Species, 1859, he did not think it answered the question. He really neither agreed nor disagreed. He thought that Darwin had left the big question unanswered, which was species change. And there is some truth in that. So what does Darwin do? What does he propose? Well, he proposes natural selection, a survival of the fittest, preservation of favoured races in the struggle for life. Every mating produces offspring with some genetic variation, and the environment acts as a kind of sieve, gradually enabling those most fitted to it to flourish, to pass on their heritable characteristics, and so, step by step, to change and eventually to separate into different species, which is a process that Darwin did not fully account for. When looking at various theories, it's good to remember that the work of any scholar is often driven by their concern with the objection that they are aware of. Nobody is more aware of the weaknesses of your work than you are yourself, and you will often, consciously or unconsciously, be very defensive about this, almost excessively so. And in 1844, we have Darwin writing in his notes, "Better begin with this, gradualism. If species really, after catastrophes, are created in showers the world over, my theory false." Well, we can't have that. So, in The Origin of Species, Darwin dogmatically states, nature always proceeds by the smallest of steps, she cannot make a leap. And that is merely a dogmatic assertion. There's no real evidence for that. And, of course, people can say, well, what about all these gaps in the fossil record? I think that one particularly fascinating element of this history is the idea of the missing link that everyone was supposed to be looking for, that if you could find a link between one creature and another creature, that would be evolution proven. And of course, Darwinists always have a get-out-of-jail-free card, gaps in the fossil record. So Darwinian evolution is what's known as phyletic gradualism. Change occurs at a slow, constant speed, although not necessarily, and according to Richard Dawkins, it could just as well be a slow, variable speed. I cannot overemphasize how welcome this was. There is a myth that the publication of Darwin's book had every Christian in the English-speaking world in uproar about this terrible proposal. Well, it caused a fuss, but in 1844 there was published anonymously a very popular book indeed called Vestiges of the Natural History of Creation, which it was written by Robert Chambers, and it proposed species change, but driven by the deity. There seemed for many people to be no reason why God should not work through a process of species change. Whether species change or not does not really diminish from the glory of the Creator, and one might well argue that a world in which species constantly evolve and change is rather more magnificent than one that's simply populated by a lot of pre-formed specimens that are incapable of any significant variation. It's difficult to overemphasize how much Darwinism fitted in with the ethos of the times. We have here Darwin saying, natural selection is daily and hourly working at the improvement of each organic being. It would be hard to imagine a more Victorian sentence than that. Isn't that what we should all be doing? I'm not being sarcastic here. I think it is what we should all be doing. We should be daily and hourly working towards our own and society's improvement. And nature is setting a good example and doing exactly the same thing. Remember, this is gradual improvement. This is England. If you're not in England, it'd be lovely to have an international audience here. But if you're not in England, the English love to give people opportunities. The English love to talk about self-advancement and self-improvement, but you can only go very, very slowly. In England, if you work very hard and do very well, in 3 or 4 generations, your family just might be accepted into society. So this was a compromise between a rigid system of the divine right of kings and essentialism, in which the rich man in his castle and the poor man at his gate were ordained by God to their places in life, and on the other hand, between a revolutionary French system in which the world is turned upside down to a nice British system in which the Mr. Pooters of this world could dream of having dinner at the Guildhall one day and slightly improving their social circumstances. There's a Darwin project. Almost all of Darwin's work, his notes, are available online, and there is an absolute mine of material. His thought processes are evolving, so one can extract from this vast mine all kinds of little nuggets of information that really don't sound like people's idea of Darwin at all. So selection acts only by the accumulation of slight or greater variations caused by external conditions. Well, okay, that's just a way of talking, just as Geoffroy and Knox have said that environmental changes cause evolutionary change. So it does in Darwinism. It doesn't literally mean that the environment causes the change, so we'll let him off the charge of Lamarckism there. However, I think there can be little doubt that use in our domestic animals strengthens and enlarges certain parts and disuse diminishes them, and that such modifications are inherited. Well, that's Lamarckism. Also, it is absurd to talk of one animal being higher than another. That's Knoxism, although we know that Darwin was trained in Edinburgh. It's almost certain that he heard Knox lecture. We know he read Knox's books, but we don't know what influence, if any, passed between the two men. A theory now that many people will know by one of the phrases associated with it, hopeful monsters. I've already used the term hopeful monsters, but it actually belongs with the theories of Richard Goldschmidt, who posited a type of macroevolution. Evolution by sudden jumps, saltatory evolution. Here in 2010, we see a critique of that. Single gene changes that confer a large adaptive value do happen. Indeed, they do. They are not rare. Indeed, they are not. They are not doomed, and when competing with small effect mutations, they tend to win. Well, do I hear an amen to that? Some things don't happen gradually. You can have 6 legs or you can have 8 legs, but you can't have 6.01 legs. Goldschmidt's theory was heavily criticized by scientists. I not only don't have time, but I don't have the knowledge to go through the genetic and the paleontological evidence for different forms of evolution. And the general overview would be that the evidence is scanty and the theories are many, and evolution is such that you can't really prove it. You can find evidence that supports your hypothesis, but dealing with changes that occur over epochs, it's just not possible to observe them. It's not possible to experiment on them. It's difficult to make evolutionary theories falsifiable. In biology, theories tend to go through 4 phases. Initially, they're regarded as outlandish and odd. Then they become part of the mainstream and are accepted as dogma. Then somebody challenges them and finds them to be incomplete explanations, or as we would say nowadays, discredited. And then some historian years later pokes over the embers and says, well, maybe there was something in them after all. And we know now that there are developmental macro-mutations in rate genes and controlling genes that make macroevolution a real possibility. Perhaps the most outlandish of the theories, I use outlandish in the sense of distant from the others, in a different ballpark altogether, is that of the Jesuit priest Pierre Teilhard du Chardin. His theory, as one might hope, was orthogenetic, so there's purpose in his evolution. It's directional. He proposed that animals were drawn through the evolutionary process towards an omega point, and that this process was characterized by increasing complexity and increasing cerebral functions. His work is esoteric and complex. My understanding of it is that he's saying that basically God creates himself. Complexity increases and increases until eventually there will be creatures so complex and capable of such magnificently deep and profound thoughts that they will appreciate, participate in, or perhaps even be the mind of God. It should go without saying that as a Jesuit, he is as heretical as you can get, really. But the theory is a good example of how Darwinian evolution and classical theism, or at least some kind of pantheism, can be combined to give a view of evolution that is still teleological. Much more of the mainstream is Ernest Mayr, whose work did much to suggest ways in which speciation might occur in Darwinian evolution. Mayr is associated with the modern definition of a species, that is, a group that can only breed among themselves. Be aware that prior to this, it was regarded as possible for different species to breed, and so, for example, when people like Knox talk about different species of men, there is no need to get offended. The term doesn't mean what it means now, it just means different kinds of men, and you also hear people talk about different species of dog. It just means different kinds. According to Mayr, evolution acts on the whole organism. Richard Dawkins' selfish gene is brilliant conceit, but most biologists would still go for selection pressures acting on the organism as a whole. You can also interpret evolution as acting on groups. Meyer explained the gaps in the fossil record by relatively rapid speciation, but that isn't macroevolution or saltation. It's a forerunner of punctuated equilibrium. Just in case you were wondering, the universe has no purpose. George Gaylord Simpson wrote Tempo and Mode in Evolution in 1944. He proposed that there could be shifts in the adaptive fitness landscape, which is basically the environment, that led new species and indeed new families and orders and classes to form rapidly. But again, this is relatively rapid change, not macroevolution. Nature for Simpson is a Heraclitean fire. Everything is constantly changing all the time. If it seems that not much is going on and that some species have remained unchanged for years, then I would draw your attention to the lovely Red Queen hypothesis. This is from Alice in Wonderland, where Alice says basically that in her own land, if she ran this fast, she'd travel a long way. And the Red Queen says, what a very slow country, she says, in this land you have to run as fast as you can just to stay in one place. So because the environment's constantly changing, animals have to evolve in order to keep up with it. The final theory I want to mention is Niels Eldredge and Stephen Jay Gould's punctuated equilibrium. This is a development of quantum evolution that's a little bit closer to gradualism and is a compromise position, a sop, if you like, to macroevolutionary biologists that accounts for some more rapid changes, but again, rapid is used in geological terms. Why are there so many theories? What exactly is at stake? Remember teleology. Teleology is purpose. The idea that evolution is heading in a certain direction, that there's a certain outcome which is the aim or purpose of the evolutionary process. It's very easy in biology to fall into teleological thinking. So phrases, for example, such as the wings were made for flying, or the legs were designed for walking, are teleological. It's goal-directed evolution, also known as orthogenesis or progressivism. If we go back to the 19th century, Carl Ernst von Baer, there's an endless supply of German aristocrats in the field of embryology, proposed a form of transmutation of species driven by a teleological force in nature. This mysterious force in nature, again, which is kind of a bit godlike, but not exactly God. Teleology invokes discussion. Knox isn't a teleologist, nor is Geoffroy. Teilhard is. What about Darwin? I mean, Darwin's the big one. And you decide. Read his works, read his critics, read his commentators. Some people say he is, and some people say he isn't. People find teleological writing in his work, and then others will say, well, it's just a mode of expression, it's how we talk about things, we don't really mean it. Saying that writers on evolution only sound teleological but don't really mean it is a bit like saying that the Pope only really sounds Catholic but doesn't believe it. Although now I think of it. So who's afraid of the big bad teleologist? Well, for some biologists, the problem is that it's part of classical theism. Once evolution has a purpose, then God steps out from behind the curtain. I think this is a misuse of science, because if you are driven by a desire to prove that God doesn't exist, and that shapes your thinking, it's a misapplication of science, because evolutionary theories do nothing one way or another in theological terms to prove or disprove the existence of a deity. So I think that is rather a straw man. There's no reason to shun teleology for that reason. You can always evoke this mysterious life force that everyone likes so much nowadays, and indeed Teilhard, as a Jesuit, is very popular with these New Age types, as Jesuits tend to be. Teleology implies that there are structures anatomically and physiologically designed to perform a certain function. Well, why would that matter? There's a song from when I was a child in the 60s called "These Boots Are Made for Walking." Well, for non-teleologists, no, they weren't. Your boots might have been made for walking, but your legs certainly weren't. They just happen to be used for that purpose. Does it matter? Well, of course it does, because if you're teleological, things should be used for their intended purpose, shouldn't they? Like genitals, for example. Well, let's not go there. Some people would say that teleology can't be explained by science, only by analogy. That it doesn't mean anything in scientific terms to say what something is for, only that it does fulfill that purpose, and that any kind of intent or directionism is wrong. This is, I think, the scientific equivalent of the so-called intentional fallacy in literature, that you read a text according to your interpretation of the text, not according to the interpretation that the author intended, and that the text doesn't have any meaning outside of itself. One of the greatest 20th century biologists, J.B.S. Haldane, did I mention that he was a traitor who spied for the Soviet Union and was a cheerleader for Stalin? He famously wrote, "Teleology is like a mistress to a biologist." Well, he'd know, wouldn't he? He cannot live without her, but he's unwilling to be seen with her in public. So, apart from people who want to adapt evolution for their own theological ends, why is teleology still around? To begin with, it fits in with the narrative of progress, which, going back to Whig history, most people like. Most people like the idea that there's an inherent progress. I had a colleague who would start his lectures on the coronial system by saying that the British coronial system has remained largely unchanged since the 12th century, and therefore it must work reasonably well. This, of course, is the opposite of what people are expecting to hear, because we're regularly told in Britain that if something hasn't been reformed for a few years, it's due to be reformed again soon because it's antiquated, like those lovely old Victorian hospitals with nice big windows and high ceilings. In biology, part of the notion of progress comes from one image, an iconic biological image, Rudolf Zallinger's The March of Progress, which is actually called The Road to Homo Sapiens. Everyone has seen this or seen some kind of parody of this, and the picture speaks more than 1,000 words. The apes are marching forwards to become humans. Of course, it's been parodied, it's been reversed, but it doesn't matter. It fits in with most people's mindset that change is a good thing. Then we have the fact that not most biologists are vivisectionists, but most vivisectionists are biologists. Therefore, if there's no progress, if humans aren't higher than other animals, then why are we cutting them up in laboratories? While I don't have time to discuss the philosophy of religion in relation to evolution, I do just want to point out that for all the supposed opposition between Darwinism and classical theism, the filter of natural selection does not rule out design. In order to be successful, a company selling handbags have to sell their product to a fickle and capricious set of shoppers prepared to spend often large sums of money on vanity products. And it can be very difficult to predict what will become popular. I've personally never seen the appeal of Louis Vuitton, but there you go. If Louis Vuitton would like to sponsor me, I would happily change my mind. However, although the success of the company depends on the handbags being selected, often perhaps by a largely random or capricious process, the handbags are still designed. Therefore, there seems to be no reason why the creator, who, according to many believers, gives Christians free will in order to see if they sin or not as a kind of challenge, and then tries to push them back onto the right way, there seems to be no reason why that creator should not enjoy creating endless micro-mutations in order to meet the challenge of getting past the net of natural selection. Teleology is a kind of progress, and it's bound up with the philosophical notion of progress. Progress for centuries meant movement in a forward direction, so people spoke about the royal progress, not walking round in a circle but going from one place to another. But this use of the word can be difficult to separate from the notion of progress as an abstract concept that means everything's getting better all the time. The word wasn't used to mean advance from worse to better until 1742, and there wasn't a word progressive until the 1890s. As with Philip Larkin, you can recognise me by progressive elimination, just eliminate all the progressives. In the 19th century, the formative influence on evolutionary theory was the French Revolution. In the 20th century, the biggest influence were the two world wars. It was just about possible to portray the French Revolution as an exercise in enlightenment and social development. Personally, I find it hard to wish ill on anyone, but as William Wordsworth described the French Revolution as a pleasant exercise in hope and joy, I do always find it a bit of a pity that he didn't manage to get himself guillotined, because it just might have revised his opinion. As Thomas Hardy put it in the 1920s, after 2,000 years of mass, we've got as far as poison gas. The world wars were a problem for organised religion, and they were a problem for teleological evolution, because maybe things don't get continually better in the same way. Maybe they just get worse, or maybe there isn't any progress at all. Maybe there's just change. As Knox put it, progress towards what? In conclusion, I present this summary of the different theories and how they relate to one another. For anyone in the biological sciences, evolution is something you need to know about because it made us what we are. Indeed, it's something that everybody needs to know about because it has operated and will operate, and we need to understand and think about its operation. We also need to think about how our own beliefs and preconceptions influence the theories of evolution that we may or may not prefer. Evolution is a topic that evokes strong opinions, and it often evokes the strongest views in people who don't really understand it. Either there are biologists who've never troubled to study theology, who think they've managed to disprove the existence of God, or there are theologians who don't understand biology, who just think that the whole thing can't be true. Perhaps what I was told about the study of the doctrine of the Holy Trinity is also true of evolution, that if you think you've understood it, then you haven't really understood it at all. From Essex, goodbye.